Swayam Prabha. Digital India. Educated India.
Good day to everyone. This is lecture number 11, representing texture using inverse pole figure. Okay. So, let us start. The concept that will be covered in this lecture is basically texture representation using the inverse pole figure. So, you see what is an inverse pole figure, and you have got an idea of this because of our previous lectures. So, you see the orientation of the crystal coordinate system is usually shown in respect to the sample coordinate system, right, and this is basically known as the pole figure, right. On the other hand, if we represent the orientation of the sample coordinate system in terms of the HKL crystallographic pole, and we represent that sample coordinate system with respect to the crystal coordinate system. So, representing the sample coordinate system in terms of some HKL pole with respect to the crystal coordinate system is basically known as showing texture in terms of inverse pole figure. Now, what is an inverse pole figure? Basically, the inverse pole figure comes because of the symmetry of the unit cell, and say for example of a cubic material, and if we look into the stereographic projection of the cubic material, what we will see, and this is the 100 standard stereographic projection, because the 100 is at the center exactly. So, what we will see that this stereographic projection is basically made up of a number of triangles, right. You see these triangles, the triangles with corners made up of 100, 110 and 111. So, we have a triangle like this and a triangle like this, a triangle like this, another one like this, this one, and so you see if you look at this quarter part of this stereographic projection, these are made of 1, 2, 3, 4, 5, 6 triangles of corners 100, 110, 111, each one of them. So, you see there are 4 quarters like this, 1, 2, 3, 4. So, 6 into 4. So, there are 24 triangles and they are symmetrically made up of 100, 110, 111, right. And therefore, if you look in the opposite direction, there are 24 more. So, this is a kind of this is a kind of a sphere, and then in the front there are 24 triangles, there it is made up of 24 triangles, and in the back side it is made up of another 24 triangles. So, 48 triangles. So, any one of these triangles can be used to represent the texture. So, basically we can take a single triangle, and we know that this part of the triangle, this corner of the triangle basically represents the 110 axis, and this 110 pole, and this 111 pole. So, we can represent the texture anywhere inside the triangle, showing an important sample reference direction, and therefore, this is the way how we use inverse pole figure to represent the texture. So, basically rather than representing the orientation of the crystal coordinate system in the specimen coordinate system, which is basically the pole figure. The vice versa is used, the orientation of the specimen coordinate system can be projected into the crystal coordinate system. And say this is an example that we showed earlier in some earlier lecture also. And say for example, we have say 12 or 13 number of crystals present in a polycrystal material. Basically these crystals in ideal conditions should be grains, right. So, say for example, important direction is say a rolling direction, and we are showing the rolling direction of each of these crystals separately, and we can see that crystal number 1 or grain number 1 has an intensity point here. So, the R D is parallel to a certain HKL pole which has its intensity here, like that you see 2 is here and 3 is here, 4, 5, 6, like 13 is here, 11 is here, 10 is here. So, we can see that each of these grains have a particular intensity of crystallographic axis parallel to an important sample reference directions, and it could be the rolling direction or the normal direction or the transverse direction or x, y, z important reference direction of the sample, right. Using an inverse pole figure, one can obtain the important sample reference direction. So, if there are 3 important sample reference directions, we have to use 3 inverse pole figures to decipher the exact texture of that particular material. So, you see a very old paper in 1969 by Bunge and Roberts in applied crystallography showed the inverse pole figure for a rolled sheet, and they showed that this is for a cubic crystal, polycrystal, cubic polycrystal, and they showed the high intensity points here at 111 poles, and this intensity point reduces, and then there are various low intensity points present here. So, you see that there is a huge spread in the texture component, and basically the component does not seem to be a single component, but it is spread from here 111 to 323 to 211 and 123, and thus forming a kind of a fiber, right. So, not the you see that the important sample reference direction, that particular one, say it is the rolling direction, does not have a single component along it, right, single crystallographic pole along it. It has multiple pole along the rolling direction, right, and it can be shown using this inverse pole figure. On the other hand, you see the another paper, and this is a relatively new paper, 1998, not new, very old paper by Rowlett and Wright in texture and anisotropy. They showed the inverse pole figure of titanium, and you see deformed titanium, which is basically a hexagonal close packed material, and you see that the inverse pole figure shows 3 important sample poles or directions, that is 001, and these are Miller-Vivet indices, which we have learned in previous classes, and 112 bar 0, 101 bar 0. So, one can observe that the texture intensity is very high along the 101 bar 0, might represent a very important sample reference direction, and then it reduces. So, there is a very large spread, right. And so, in this way you see that texture can be represented in terms of inverse pole figure, and in this case the reference system is not the important sample reference direction, but the reference systems are the important crystal reference directions, and thereby important sample reference directions are shown here, right. So, most of the time the inverse pole figure is usually shown for axial deformation, and why? Because in an axial deformation, like an extrusion process or a drawing process, there is an important direction, a single important direction, which is the axial direction, and that is here the extrusion axis. In some case it could be the drawing axis, like that. So, say for example, if we have a rod produced by an extrusion process, and it has a certain number of grains with a particular intensity of texture component. Say these components, they are specially separate out, but they have certain intensity, and so that it shows up as an intensity in the texture. Then you see that these are basically those crystals which shows that the extrusion axis is parallel to 110. So, these are 110 axis. So, if the extrusion direction is along the 110 axis, then we can show the extrusion direction in the crystal frame of reference using this inverse pole figure abbreviated as IPF here, right. So, the texture corresponding to the extrusion axis is shown as high intensity points spread from 7 to 1 in the 110 direction of the inverse pole figure. So, this is how the inverse pole figure is basically used to represent the texture, and most of the time it is used to represent the texture of material which has been axially deformed. So, axial texture usually shown by inverse pole figure to describe them, right. Okay. So, you see, now let me give few examples that can lead you to understand more in detail about the inverse pole figure. Now, let us say we use a rolled sample, and the rolled sample has three important sample reference directions, that is RD, ND and TD, and we use the same cube texture component which is 100001. Now, if we use, as I said, and we have seen about this texture cube texture component a lot in the previous lecture too, and then you see that we have RD parallel to the x, y and z of the cubic unit cell, which is basically the 100 axis. And so, if we draw the inverse pole figure, we draw the RD inverse pole figure, TD inverse pole figure and the ND inverse pole figure, so as to represent the texture as a whole in using three inverse pole figure. So, what would be it? So, in the RD inverse pole figure, you see the inverse pole figure is made up of 100, 110, 111 all the time, and so you see RD is parallel to 100. So, it will be showing high intensity here. The TD is parallel to y, which is another 100, so it will be showing intensity points here, and the ND is parallel to 001, which will also lead to form an high intensity point here. So, you see, using three inverse pole figures, we can represent the texture for a particular cube component here. So, rather than using a cube component, if it is a rotated cube, now you see it is 100011. The same examples that we showed for the pole figures, and so you see ND is parallel to 001. So, if we look into the ND inverse pole figure, we see that high intensity is coming along 100. So, in the 100 pole family, right. On the other hand, if we look in the RD, and it is, you see, it is in between x and y. So, if x is 100 and y is 010, so the RD is parallel to 110. So, the intensity of RD will come in the RD inverse pole figure at 110. On the other hand, you see TD, which is perpendicular to both RD and ND, forms along another 110, which is perpendicular to RD 110, right. So, it forms at another 110. So, the TD inverse pole figure will also show an intensity point at 110, right. Now, let us talk about the Gauss texture component 110001 type texture component using the inverse pole figure, right. Now, you see that in this case ND is parallel basically towards this direction, which is 110, right, 110, and RD is along Z, which is 001. So, the RD inverse pole figure will show intensity at 001, whereas the ND inverse pole figure will show intensity at 110, right. Now, what will be the intensity point along the TD? And you see that in this case also the TD is parallel to another 110, and one can find out this by using a cross product between the RD 001 and the ND 110 to obtain that TD is also along another 110, and therefore, the TD inverse pole figure shows the position 110. So, let us use the 111 110 texture using the inverse pole figure, and this is the same example. And so, you see the ND inverse pole figure shows its intensity along 111. On the other hand, the RD inverse pole figure shows its intensity at 110, and where will be the intensity of TD? Now, you see that if we make a cross product of 111 and 110, you will find that the intensity of TD comes at along 112, and so 112 will be in the equal angular division between 111 and 100, and so you see it will come somewhere in between, and if you add 100 plus 111, somewhere here it will be 112. And we can obtain this using the stereographic projection of 111, and you can see that if 111 at the is at the center, and you can see if 011 is at 90 degrees to 111 here, then at exactly 90 degrees to both, that is here, this is 112 poles or positions, and this one can find out by adding these two 1 bar 0 and 1 bar poles, and if you add them, it forms 2 1 bar here, and thereby the TD pole that is shown by the inverse pole figure has the intensity point here, which is 112. Now, let us go ahead, and you see that as we observed in the pole figure, right, more than one components may present in the material, leading to formation of texture fiber rather than texture components. So, say for example, we have used two different not all the 4, but 2 different cubic unit cell, and we have shown them in the inverse pole figure. And you see that if we look at the ND, you see we have intensity points at 100. So, it can be cube texture, it can be rotated cube too, it has intensity points at 110. So, it can be gauge texture, it has intensity point at 111. So, it could be 111 1 bar 0, right. Now, let us look into the RD, and if we look into the RD, we see that RD is parallel to 100, and thereby it can represent this cube component. The RD is also parallel to 110, so it can represent the rotated cube component. RD as parallel to 100 represents the gauge texture too, and RD also represent this texture. So, if all the 4 texture are present, then the inverse pole figure for RD, TD and ND may look something like this, and thereby you see when this texture component will have a rather large spread, then they will not look as separate component, but they will look as fibers. And like this hypothetical example, we may have cube, gauze, S, brass and copper components of these Miller indices present all over at the same time in case of face centered cubic material, as we have seen earlier, and thereby leading to formation of fiber texture, which could be easily represented not only in by using pole figure, but by also using inverse pole figure. So, based upon the utility and the usefulness, sometimes we use Miller indices, sometimes we use pole figure, and sometimes we use inverse pole figure to represent the texture components or texture fibers, right. So, it can be concluded that inverse pole figures, that is IPF in abbreviation, can be used to represent texture as we represent texture using pole figure. In inverse pole figure, the orientation of the specimen coordinate system is projected into the crystal coordinate system reference frame, right. The IPF is one of the 48 stereographic triangle obtained from the stereographic projection due to crystal symmetry, and this I am talking about the cubic crystals only. The number of stereographic triangle present in case of orthogonal, orthonormal or triclinic or hexagonal system will or may be different. The IPFs are mostly used to show texture fiber obtained during axial deformation. So, IPF maps IPF inverse pole figures are mostly used to show the texture fibers which is obtained during extrusion, drawing or any other axial deformation like compression, open die forging kind of situation. More than one IPF corresponding to important sample reference planes and direction is required to represent the texture. So, you need if there are 3 IPF, then you need RD IPF, TD IPF and ND IPF to represent the texture. Thank you.